Okay, so what we just did was we showed with this representation that the idea when you multiply two complex numbers together, what happens is you multiply their norms together and then you add the angles to figure out what's going on. That's pretty neat. Similarly, if we did this, z1 divided by z2, this is going to end up being r1 e to the I theta 1 divided by r2 e to the I theta 2. This is the same as r1 over r2 e to the I theta 1 minus theta 2. So if you divide, you end up dividing their norms and you subtract the angles between them. And what I was thinking about the other day was if we have z, what is 1 over z? I mean, think about this. You do, suppose that, we're talking about 2. In real numbers, what is 1 over 2? What's the relationship? Besides the fact that if you multiply them together, you get 1. How would, and my 2's, this was a bad choice because my 2's look like z's. This was just supposed to be 2, and I just picked this at random. I was thinking, suppose I have z. What does 1 over z kind of look like? It's not, because remember, here is, if z is up here, if z is up here, the complex conjugate is down here with the same length, the same norm with the negative of the angle. So clearly this is, in general, nothing like 1 over z. What happens to 1 over z? And as I mentioned, I'm spending way more time on this than is called for in the book, but I just think it's that interesting and I'd like to. You feel free to skip forward a little bit as long as you're capable of answering all the homework questions and feel comfortable. Because I don't remember if this was in there or not. I just like this stuff. Suppose we have this, z equals r e to the I theta. What does 1 over z actually do? Right? And so think about it. For real numbers, if you have 3, what does that mean here? 0, 1, 2, 3. What is 1 over 3? Well, 1 over 3 would be something like this, 1/3. So in this particular case, we see that this is just, we can think of this as a scalar, although if you want to say plus is in this direction and minus is in this direction, you could call this a vector, and we're going to be talking more about vectors. But basically, it just kind of took the length back this way. What's going on with this? All right, so let's see if we have this. Suppose that this is our picture here, a plus ib. This theta is the arctangent of b divided by a. So this is z. What does this look like? Well, this is going to be 1 over r e to the I theta. This could be written then as, we could do this. This is 1 over r e to the I theta times e to the minus I theta, e to the minus I theta. E to the anything is never going to be 0, so we just multiply both sides by 1. Notice that e to the I theta times e to the minus I theta is just going to cancel. It's going to be 1. That this will be e to the I theta minus theta, which is e to the I 0, which is just e to the 0, which is 1. So this is 1 over r e to the I minus theta. Well, so what is this? Remember, when we did this, we know that if z is r e to the I theta, z complement, or the conjugate rather, is r e to the minus I theta, right? We know this, we already went through this. So that means, and I should have actually erased this. This is neat. I actually haven't done anything like this for a while, and I was just feeling kind of curious because I had too many Red Bulls today. So that means that if we divide this by r squared, divided by r squared, this is going to be, so this is equal to z bar divided by r squared, which is 1 over r e to the minus I theta. And this, of course, is equal to 1 over z. So if we take z and use it in the divisor, we end up saying that this is the same as the complex conjugate divided by, well, what is r squared? we know that the norm of z is the square root of a squared plus b squared, and this is r, so r squared is going to be the norm of z squared, right, which is this squared, which will be a squared plus b squared, which will be r squared. So interestingly enough, and like I say, this won't be in your homework, I don't think. I don't remember seeing it anywhere in there. But so if we have z is equal to r e to the I theta, 1 over z is equal to, what do we have here? The complex conjugate divided by the norm squared. Is that important? I suppose it depends on your application. It's just interesting. If you'd want to impress me, or whoever your instructor is, being able to figure out things like this will go a long way to that end. And what I mean by that is, if you want to get an A, these are the kinds of things that you're going to need to be able to do. If you're going to be a real scientist or an engineer, these are the things that you will be doing one way or another, undoubtedly. Okay. So how much time do we have on this one? 3 minutes? Okay. So. Okay, where do we need to go next? Oh, so we should go to de Moivre's actual theorem. So we know that z equals e to the I theta equals cosine theta plus I sine theta, right? That means, my yellow. That means that z to the n is equal to e to the I theta n, which is e to the I n theta, which is cosine n theta plus I sine n theta. I love this yellow. Hopefully, is this coming through reasonably well?
Mm-hmm.
Okay. So we should try this out, right? Let's see what happens. Suppose that z is equal to 1 plus I. Incidentally, I just made this up. Let's work out what this is. First, in this is a plus ib. So a is equal to 1, b is equal to 1. What's my information here? I need the norm of z, which is 1 squared plus 1 squared square root. This is the square root of 2. And I also need the arctangent of b divided by a, which is 1. This is pi over 4. Okay, so I can write this. Z is equal to r, which is the square root of 2, e to the I, pi over 4. Let's just see what z squared is. So z squared, the old-fashioned way, would be 1 plus I, 1 plus I. Foiling this out, this is 1 plus I squared plus I, and this is just foiling it out. I squared is negative 1, this is 2I, right? Let's see if that comes true here. Z squared will be the square root of 2 e to the I pi over 4 squared. This square will hit here, it'll hit here. This is going to be square root of 2 squared is 2 times e to the I pi divided by 4 times 2 will be pi divided by 2. This is 2 times cosine pi over 2 plus I sine pi over 2. Cosine pi over 2 is 0. Ooh, we're almost out of time. This is going to be 2 sine of pi over 2 is 1 times I. It's the same. And we have to go. We'll be